Welcome to our second lesson on the real numbers, covering sections 1-5 through 1-8. First major topic in this next section is the order of operations, the rules that mathematicians have developed on how to solve equations. First thing you always have to do is take care of any parentheses, absolute values, fraction parts that might appear in the equation. After all of those are completely simplified, the next item calculated is all the exponents. After the exponents, the multiplication and division, working left to right. And finally, the addition and the subtraction, working left to right. Let's work a couple examples with this in mind. First thing in order of operations is the parentheses, parts of fractions, and absolute values. So on this problem, it would be all these parts. When we simplify those parts, the equation will end up looking like this. Now you notice there's still an absolute value in the equation. You'll remember absolute value means the distance from 0, which makes it always positive. So that -3 absolute value is a +3. Now that we're done with all of those, the next thing in order of operations was the exponents. We are going to solve the exponent 3 squared, and now the equation looks like this. The next section we work on is the multiplication and division, working left to right. So we'll do the division 12 divided by 4, and the multiplication 5 times 9. Finally, at the end, we do all the addition and subtraction, working left to right. 3 plus 3 first is 6, and finally 6 minus 45 is -39. Now we're going to tweak this order of operations and take it to an algebraic level. I'll have an expression like 3a minus b, and I'm going to tell you that a equals 5 and b equals -3. What that's saying is the letter A functions exactly like the number 5. So anywhere I see an A, I could replace it with a 5, and it would still be exactly the same. So that's the first thing I'm going to do in this expression. Instead of 3a minus b, we're going to go 3 times 5, because that's what A is, minus, and we're going to replace the b with a -3. From here, it's an order of operations problem where we do the multiplication first, 3 times 5, then the addition and subtraction, going to add the opposite, like we talked about yesterday, and end up with my final answer of 18. Now that we've kind of looked at how it works with a variable or a letter being the same as a number, you can work on equations and decide, is this number, the 4, the correct answer for that x in this equation? Is 5 times 4 minus 2 really 18? Well, we'll start by substituting in a 4 for the x and work order of operations. 5 times 4 first, finally minus 2, and yes, they are equal. Yes, 4 is the correct solution to this equation. Let's try one more. Is -1 the solution to 5x minus 4 such that it equals -1? To test it, we're going to put -1 in place of that x, so we have 5 times -1 minus 4. Multiplication first, 5 times a -1 is a -5. -5 minus 4, we're going to add the opposite, makes it -5 plus a -4. And we know now that that is going to be -9, which is not the same as -1. So no, this is the wrong solution. -1 is incorrect. There's a couple of properties of real numbers that I want to talk about today. We are going to use these properties to simplify equations to make them easier to use. The first one is called the distributive property. The distributive property is going to have a number in front of something in parentheses. And if we want to simplify and get rid of the parentheses, we can take this number out front and multiply it by both parts of the expression in parentheses. So negative 3 times 4x, well, negative 3 times 4 is negative 12. And then we'll distribute the negative 3 also onto the minus 6 part. The minus 6 we're going to treat like it's a negative 6. So negative 3 times negative 6 is a positive 18. That's the distributive property, probably one of the most important of our algebra career. The associative property. Associative property basically says it doesn't matter which part you do first. In the first, on the left side of the equation, you'll notice it says 2 times b first. Then you multiply by the 6 on the outside. This side says do the 6 times 2 first. Then multiply by the b on the outside. With multiplication, if it's all multiplication, the order does not matter, and it is associative. It doesn't matter which part you do first. I want to take a brief moment to notice the difference between this and the example before it. In the example before it, we used the distributive property because there was a minus sign in between the terms. If there's a plus or minus between terms, we have to use the distributive property. Next is the commutative property. That means things can switch place. 5 plus x is the same as x plus 5. And the additive inverse simply means if you add something to its opposite, you're going to end up with 0 for your answer. Multiplication property of 0, that just says anything times 0, the answer will always be 0. So let's try and simplify using our properties. First thing I notice is we've got some parentheses to simplify through. So we're going to distribute this negative sign through the parentheses. So we're going to have a negative m and a negative negative 2. Well, two negatives make a positive. And so next it looks like this. Next we'll use the commutative property to move stuff around. We're going to combine the m's together. 2m minus m is just an m. And we're going to combine the numbers together. 6 plus 2 is 8. We can always combine terms like this that look exactly the same. The m and the 8, though, are different. One has a letter, one doesn't. We cannot combine those. Let's look at one slightly more complex example. Here we have a number in front of parentheses, so we're going to multiply that 2x, and the negative is going to come with it, so it's actually negative 2x is going to be multiplied through the parentheses. When I do that, we get negative 6x squared plus 14x. Now I have to take a moment to look for like terms. X squareds. There's a negative 6x squared and a negative x squared. That's going to give me negative 7x squared. The 14x has nothing in common with it, and the 7 has nothing in common with it. And so this is our final simplified equation. Please note that the x squared and the x were not combined because they are not like terms. Homework, I want to remember with all these slideshows, it's not a detailed review. You are expected to read the book for more involved examples and explanations. The assignment for today is off page 80, number 63 through 129 odd. And as always, all the homework is due this Tuesday, which is going to be September 30th by 3 p.m. I think yesterday's slideshow had a misprint and said October 30th. It's supposed to be September 30th. It's due this Tuesday. Thank you. We'll see you next time.